Most dietary carbohydrate is burned as fuel within a few hours of absorption. Galactose and fructose are quickly converted to glucose, which is catabolized in this reaction. This reaction transfers energy from glucose to ATP. In the body, this process is carried out in a series of small steps, and in the presence of oxygen, one glucose molecule yields 36 to 38 molecules of ATP. The first step of this is called glycolysis. It splits the glucose molecule into two molecules of pyruvic acid in a series of steps, and they happen in the cytoplasm. Step 1 is phosphorylation, in which the enzyme hexokinase transfers an inorganic phosphate group from ATP to glucose. This produces glucose 6-phosphate. Step 2 is priming. The glucose 6-phosphate is rearranged to form fructose 6-phosphate, which is phosphorylated again to form fructose 1,6-diphosphate. This primes the process by providing activation energy. Step 3 is cleavage. The fructose 1,6-diphosphate splits into two 3-carbon molecules, which generates two molecules of phosphoglyceraldehyde, which is also called PGAL. Step 4 is oxidation. Each PGAL is then oxidized by removing a pair of hydrogen atoms. The electrons and one proton are picked up by NAD+, yielding NADH and a proton. At this step, a phosphate group is also added to each of the carbon-3 fragments. Finally, in the next two steps, phosphate groups are taken from the glycolysis intermediates and transferred to ADP, converting it to ATP. The 3-carbon compound becomes pyruvic acid. The net end products of glycolysis are therefore 2 pyruvic acids, 2 NADHs, 2 protons, and 2 molecules of ATP.